Hello everyone, today we'll be discussing about the block allocation. So, ICANN, that is Internet Corporation for Assigned Names and Numbers, that is ICANN, allocates the addresses to an internet service providers. So here, two restrictions are applied to allocate the block. So we have to remember those two restrictions which are required when we allocate a block. So the first one is that the number of required addresses, which is capital letter N, should be always a power of 2. So that is calculated by using 2 power 32 minus n, as we have seen in the already the number of addresses. So that should be a power of 2. And the prefix length is calculated, however, 32 minus log n to the base 2, where capital letter N is the total number of addresses and small letter n is the prefix length. Second condition or the second restriction is that the first address in decimal needs to be divisible by the number of addresses in the block. So let us see the problem. An internet service provider has requested a block of 1000 addresses. Since 1000 is not a power of 2, 1024 addresses are granted. The prefix length is calculated as 32 minus log 1024 to the base 2, which is nothing but the number of addresses. Since it has to be the power of 2, n will be 22, which is the prefix length. So the available block is 18.14.12.0/22. So that will be the prefix length is granted to the internet service provider. It can be seen that the first address in the decimal is, if we are converting, which is divisible by 1024. Next is about subnetting. Next topic is the subnetting. Subnetting is an organization which we had already seen in the classful addressing. An organization or an internet service provider that is granted a range of addresses may divide a range into sub-ranges. So here what happens here is that the subnetwork should be carefully designed to enable the routing of packets. The total number of addresses granted always is capital letter N and the prefix length is small letter n. And the assigned number of addresses to the subnet is capital letter N to the base sub, and the prefix length for each subnet is small letter n to the base sub. The steps to be followed is the number of addresses in each subnetwork should be a power of 2, and the prefix length is 32 minus log n sub to the base 2, and the first address is obtained as prefix and decimal multiplied by the number of address, and the first address should be divisible by the number of addresses in the subnet. And also we have to follow a rule like first we have to assign addresses to the larger subnetwork. So let us consider an example. Before that, steps to be followed is number of addresses should be a power of 2, as we have seen in the earlier problem, and the prefix length of the subnetwork is calculated as the same way as the prefix length was calculated in the block allocation, and the first address should be divisible by the number of addresses in the subnet. First assign the address to a larger network. So here let us see the example here. The organization is granted a block of address with the beginning address 14.24.74.0/24, and the organization needs to have 3 sub-blocks of addresses to use in its 3 subnets. So one sub-block of 10 address, one sub-block of 60 address, and the one sub-block of 120 address. So we have to design the sub-blocks. This is very important. These problems will be surely asked in the VTU exams. You can refer to the old question paper, and also in the CPs. These problems are very important. So first thing is that we have to satisfy those 3 conditions. That is, first thing is that number of addresses should be a power of 2. Second is prefix length of subnetwork is calculated as 32 minus log n subnet to the base 2, and the first address should be divisible by the number of addresses in the subnet, and first we have to assign address to a larger subnetwork. That is very important. We have to assign addresses to a larger subnetwork. Now let us consider here. Now there are 3 subblocks and we have to use 3 subnets. So one subblock of 10, one subblock of 60 and one subblock of 120 addresses. So consider now the total number of address n is 2 power 32 minus n. So n is the prefix length, which is 24. So we get it as 2 power 8, which is 256 addresses. And the first address is calculated, first address is obtained by keeping those 32 minus 24. That means which is 8. So the LSB 8 bits are made zeros. So we obtain a first address. So this will be nothing but with the beginning address 14.24.74.0/24, which will be the first address, which is already given in the question. And the last address is calculated by making those 8 bits, which is 32 minus n, which is nothing but 32 minus 24, which is 8 bits as 1. So it will be, last byte will be 255. So it is 14.24.74.255/24. Now we assign the addresses to the subblock. To satisfy the third requirement, we have to assign addresses to the subblock starting with the largest and ending with the smallest one, which is very important. So in case if we solve it in the other way, full problem will be wrong. So number of addresses in the largest subblock we have to see now, which requires 120 addresses, which is not a power of 2. So first we have to make it as 128, which is a nearby greater than 120, that is 128 address, which is a power of 2. And the subnet mask for this subnet can be found as 32 minus log 128 to the base 2, which is 32 minus 7, which will be equal to 25. The first address in the block is obtained by making 32 minus 25, that is 7 bits to zeros, and the last address is obtained by making those 7 bits to ones, so 0 and 127. Next we have to consider a second block with the less addresses than 120, that is 60, which is also not a power of 2. So we allocate 64 addresses. Subnet is calculated, which is 26. The first address is obtained as by making 32 minus 26, that means 6 bits as zeros, and the last address is obtained by making those 6 bits as ones, so 128 and 191. Next we have the number of addresses in the block which requires 10 addresses is also not a power of 2 here. It is the least one, not the largest block. Last one, we allocate 16 addresses here, which is a nearby power of 2, and the subnet is 32 minus log 16 with the base 2, which is 28, and here the first address is obtained by making 32 minus 28, that means 4 bits as zeros, and last address is by making those 4 bits as 1, so 192 to 207. So once if we add all the addresses in the previous blocks, the result is 208 addresses, which means 48 addresses are left reserved. The first address is in the range is 208, the last address is 255. We don't know about the prefix length. So this shows, the next figure shows the configuration of the blocks, which you can see here. With respect to the division of the blocks, sub-blocks. So here you can see that this is the first address, and also we have the last address here, and these are all the 256 addresses, and this is how it is divided into the sub-blocks. So first is with the prefix length 25, then 26 and 28, and these are the number of addresses 128, 64, 16, and those are the first and the last addresses with respect to each block. That is what we have seen. Next example shows how these 4 small blocks of addresses are assigned to 4 organizations by an internet service provider. The internet service provider combines these 4 blocks into one single block, advertises the larger block to the rest of the world, and any packet destined for this larger block should be sent to this internet service provider. So overall, it is the responsibility of the internet service provider to forward the packet to the appropriate organization. This is similar to routing. You can find in postal network, no? All the packages which comes from the country, outside country, are sent to the capital and then distributed to the corresponding destination. So we can see here the address aggregation. So address aggregation will be done by the internet service providers. So these are the different blocks as we have seen here: block 1, block 2, block 3 and block 4. And this internet service provider, all packets with the destination addresses are sent to the internet service provider. Next is DHCP will be dealt in the next class. Next we'll be going through about the network address translation, so which is said to be NAT. In most situations, what happens is that only a portion of the computers in the small network need access to the internet simultaneously. So a technology which can provide the mapping between the private and the universal addresses, which are something like a global address, and at the same time support virtual private networks, is network address translation. So overall, it is a technology which allows the site to use a set of private addresses for internal communication and a set of global internet addresses for the communication with the rest of the world. So private addresses will not be seen by the outside world. So you can see in the figure here, network address translation, we can see that a site using the private addresses here, private IP addresses, and network address translation router converts these into the global addresses which will be seen to the rest of the world. How this address translation is done, you can better see here. These are the site using the private addresses, and this address, by using the router, it is converted to global address, and that will be carried by the packet. And once the destination, it reaches the destination sends back the maybe the reply with respect to the acknowledgement, or it might be the packet which is sent. So that destination will get mapped to that corresponding private address. How this mapping will be performed? So this will be performed by looking at the translation table. So let us see the example here. So the private network, there is a private network here. So the packet will carry the source address, destination address and the data. So this will be the source address, this is a destination address and the data which will be carried. So first it makes the table entry. So with respect to this private address, it makes the entry of the destination which will be the universal address. Now, which is nothing but a universal address. Now, with respect to the private network, first, the network address translation router converts that particular source address from the private address to the global address. So, it will be converted to 200.24.5.8. And in the process of communication, once when the destination have to reply back to that same sender, it accesses the table, it looks into the address, global address, which is the source address now, and it finds out from the table which is the private address. And with respect to this, the destination address will be changed to that private address and the packet will be delivered to the source. So translation table plays a main role here to transmit the packet and to get it transferred to the source back. So it is a 5-column translation table which you can see. So next class we will be discussing about forwarding of the IP packets and also DHCP protocol, which is a dynamic host configuration protocol, will be studied in the next class. So let us move back. What is that we had discussed in the previous classes is that allocating, that is the block allocation. So very important in the block allocation is that the conditions to be remembered is that the number of required addresses should be a power of 2 and first address needs to be divisible by the number of addresses in the block. So with respect to that, we had seen an example problem, and also we had seen about subnetting. So subnetting or organization that is granted a range of address divides the larger range into sub-ranges, and here subnetwork should be carefully designed to enable routing. So here the steps to be followed is that number of addresses should be a power of 2, and the prefix length is 32 minus log n sub to the base 2, and the first address should be divisible by the number of addresses in the subnet. So first assign address to a larger subnetwork, so which has to be remembered. Next we had seen about the address aggregation, and also we discussed about the network address translation. So here in the network address translation, what is that we have seen is that it is a technology which allows a site to use private addresses for internal communication and the global internet addresses for the communication with the rest of the world. So in the example you can see that there is a network address translation router which converts those private addresses to the global address, and here you can see it with the example how those private addresses are converted to the global address, and here you can see the translation process. So along with the data we have a source and the destination address, and first a table entry is made with respect to that source address, which is the destination address, that is a universal address, and the network address translation router changes the source address from the private address to the global address. And looking at the translation table, whenever this is the source address, it looks into that address which was the destination universal address, and it will map that destination address to that private address which maps with that of the universal address, which will be the destination, which will be the source address, which you can see it in the translation table. So this is how 172.18.3.1, which was mapped to 25.8.2.10, will be retrieved back by accessing the table, and thus the network address translation router changes the destination address, and that packet will be delivered to the private network. That is what we have seen it in the network address translation. So here just the thing to be remembered is that the 3 steps to be followed is that the number of addresses in the subnetwork should be a power of 2, and prefix length is obtained as 32 minus log of the addresses to the base 2, and the first address should be divisible by the number of addresses in the subnet, and first assign address to the larger subnetwork in the subnetting, and also when you allocate the blocks. So that is what we had seen, and also classful and the classless addressing. So, and also in the network address translation, remember about the private addresses and which are used only inside, and the global addresses to the rest of the world. Network address translation router does the purpose: first, making the table entry; second, changing the source address; third, the destination accesses the table; and fourth, it changes the destination address. So as a result, network address translation will be done. And this is a 5-column translation table which you can see here. So the network address translation is nothing but a technology which allows a site to use a set of private addresses for internal communication, which is only inside, and a set of global internet addresses for communication with the rest of the world. So whenever a small portion of the computers in a small network need to access to the internet simultaneously, this network address translation technology is used, which can provide the mapping between the private and the universal addresses, and also it supports virtual private network, which will be discussed later. So that is about the network address translation. So here the IPv4 address, which is used in the network layer, which is just to identify the connection of the each device, and it is a 32-bit address which uniquely and universally defines the connection of the router to the internet. And These IPv4 addresses are unique addresses. Remember it defines one and only one connections. If two connections via two network, it needs to have two IPv4 addresses, and these addresses are universal in the sense that addressing must be accepted by any host that wants to be connected to the internet. So the total number of addresses used by the protocol is nothing but the address space. So IPv4 uses 32-bit addresses, which means the address space is 2 power 32. And about the three different notations also we had seen, and also with respect to the classful, which are the different classes, and also we have to remember about how to differentiate between the classes, and also classless addressing was seen with respect to the notation, that is CIDR, and also we have solved problems to find out the first address, last address, number of addresses. Remember those equations. And with respect to the block allocation and subnetting, remember about those 3 steps to be followed. That is, steps to be followed is number of addresses in the each subnetwork should be a power of 2. Prefix length is calculated as 32 minus log n to the base 2. The first address should be divisible by the number of addresses in the subnet, and if it is subnetting, first assign address to a larger subnetwork. So next topics will be dealt in the next class, that is dynamic host control configuration protocol, and also forwarding the IP packets. So thank you.